Okay, so here's the homework for the holiday. Hope it doesn't take you too long. So starting the finance section of the course, which is chapter 8 and chapter 9. So this one here, chapter 8, modeling growth and decay using recursion. So sequences, you've known them since probably before you started school. So counting is a sequence. So obviously we're going to get a little bit more tricky, aren't we? More complicated, so it's going to be annoying for you. So a list of numbers written down in succession is called a sequence. So you know that, it's just the terminology that we use. Each number in that sequence is called a term. So here, one term, one term, one term, one term, one term. Separated by commas, nothing amazing there. If it continues indefinitely, we use an ellipsis, those 3 dots, so that continues on forever. So if we add the ages of people boarding a plane, that could be a random sequence because we wouldn't necessarily know the ages, but people just getting on at any particular order. So ellipsis, those 3 dots, random sequence. So random sequences are very, very difficult for us to do mathematically because, like I say, they're just random, they're just made up. So rule-based sequences are more like the sort of thing that we're going to be looking at, and these are the sort of things that you're much more familiar with. So here it looks like they are, to me, odd numbers. This is a sequence as a starting value. Starting value is 1. Then we add 2 to generate each term. So we're just adding 2 each time. So the rule is add 2 to each term. Nothing tricky there. Start with 1, add 2, add 2, add 2, add 2, those 3 dots, which are called an ellipsis. So we're mostly going to be looking at rule-based sequences, not surprisingly enough. So generating a sequence of terms recursively. So here's a word that you might be confused with. So we'll have a look and see if we can work out what that means. Write the first 5 times terms of the sequence with a starting value of 6 and the rule add 4 to each term. So again, not a tricky one. So starts with a 6, adds 4 each time, adds 4 each time, adds 4 each time, adds 4 each time. So the sequence 6, 10, 14, 18, 22. Write down, there's another one. Write down the first 5 terms of the sequence with the rule with a starting value of 5 and the rule double the number, then subtract 3. So double the number, subtract 3. 7 becomes our new number. So double it, take away 3. That becomes our new number. Double it, take away 3. So there's the sequence there. Doesn't get much easier than this. So we can use a calculator. All the calculations are repetitive. So the same calculations performed over and over again is called a recursion. So if we go back to this one here, generating a sequence of terms recursively. So that just means doing the same thing over and over again. Adding 4, adding 4, adding 4. That's recursively. This one here, doing the same thing over again. Double, subtract 3. Double, subtract 3. Double, subtract 3. So calculator, very handy for us to be able to do that. Use a calculator to generate the first 5 terms of the sequence. Starting value of 5, double, then subtract 3, which I think is that one there. Starting value of 3, double, take 3. So if you do this, type 5, then press your enter button. So you're on the next line. Then type times 2, take away 3, press enter again. Keep pressing it, keep pressing it, keep pressing it, and it'll do the terms for you. So type in 5, press enter, go to the next line. Then you just type times 2, take away 3, press enter, press enter, press enter, and it generates the term for you. The number of times you push it is the number of times it generates that sequence. 8B, so 8A, that was quick, wasn't it? Obviously there's some work for you to do there. So recurrence relation is a mathematical rule that we use to generate a sequence. So there's 2 starting points, there's 2 parts, a starting point and the rule. So if we go back to this one, starting point was 5 and the rule is double, then subtract 3. So we kind of know all this, just the way that we're going to write it. In words, a recursion rule to generate the sequence 10, 15, 20, 25, 30, 35, 40 can be written as start with 10, Then to obtain the next term, you just add 5 to the current term and repeat the process. So a little bit wordy. If we were doing this in Japan, we'd have to write all these words in Japanese. If we were doing it in Germany, we'd have to write them in German. So this is easy. So now we're going to use some letters and terms, and this is where it can start to get a little bit tricky. So I won't talk about that. I'll show you this table. So we have a starting value and our rule. So this is starting with 10, and the rule is add 5 each time. So basically, V0 is our starting term or our initial term. You think about it, 0 is your starting point, isn't it? So 0 is the starting point. If you think about your X and Y axis, they start at 0, 0. So 0 is our starting point. So that's our initial term. We use the letter V because it means variable, but you could have used a P or a Z or a Q or an L. So they will invariably use a V, but sometimes they'll freak you out and use a different letter. Don't be freaked. It's just the letter that they're using. And V of n is the term after n iteration. So if we do it once, if we only do the sequence once, n will be 1. If we do it twice, n will be 2. So if we go back to this one here, we've done it 1, 2, 3 times. So that would be V0, V1, V2, V3. So it's just the number of times that we do it. And this here, I think this is probably the thing that gets kids the most. It still sort of confuses me a little bit sometimes. So if you think about it, V at the starting point, it's 0. So n is 0. So the next one will be 0 plus 1, which is 1, which is our first term. The next one, it'll be 1 plus 1, which is 2. So basically, it's just saying that we're adding 1 each time. So it's just first term, second term, then it'll be the third term, the fourth term, the fifth term, the sixth term. So here, this is the way that we write this mathematically. So instead of saying start with 10, then add 5 each term, repeat the process, means that V0 is 10. That's our starting point. And our rule is we add 5 to each. So the next term is the previous term plus the rule. Previous term plus the rule. Previous term plus the rule. And every time we do this, n increases by 1. So initially, it'll be 0, then it'll be 1, then it'll be 2, then it'll be 3. So maybe doing some questions on this will help, but I have some more information here. Each time that you apply the rule, it is called an iteration. Write down the first 5 terms of the sequence defined by the recurrence relation V0 equals 9, Vn plus 1 equals Vn minus 4. So what does this mean? It means the starting value is 9 and we take away 4 each time. So there's nothing tricky there. It's just that is the way that you need to learn how this is written. Starting value 9, take away 4 each time. Showing the value of the first 4 iterations. So it just means we do this 4 times. Starting value is 9. Next term is 9 minus 4, which is 5. 5 take away 4 is 1. 1 take away 4 is minus 3. Minus 3 take away 4 is minus 7. So write the answer. The sequence is 9, 5, 1, minus 3, minus 7. Showing the values of the first 4 iterations. So remember, that's the starting one. So that's our initial value. So there's our 1, 2, 3, 4 iterations. On your calculator, type 9, press enter. Just type minus 4, and then just keep pressing the number, and it'll work it out for you. 1 press, 2 press, 3 press, 4 presses. A sequence is generated by the recurrence relation V0 equals 300, Vn plus 1 equals 0.5 Vn, take away 7. What this means is our starting value is 300, and then what we do each time is we half it, take away 9. Half it, take away 9. Half it, take away 9. Use your calculator to generate these sequences and determine how many terms of the sequence are positive. So because we're taking away 9 each time, it's going to make, and we're halving it. So if we half it, it'll get smaller. If we take away 9, it'll get smaller as well. So eventually it's going to become negative. So the first one, 0.5, 300, half of 300 is 150. Take away 9 is 141. So if you type 300, press enter, then just type times 0.5 minus 9, press enter, you get 141. Keep going until you get a negative number. So first iteration, second, third, fourth, fifth. How many terms of the sequence are positive? The first 5 terms of the sequence are positive. 1, 2, 3, 4, 5. There's some stuff for you to do. Get all this done over the holidays. So our first lesson back, we can start on 8C. Good luck and good working.